All right, let's work through this semicircle problem carefully, because the diagram may look a little complicated, but the actual idea is based on two simple right triangles. We have a semicircle, and two vertical segments are drawn upward from its diameter to the curved edge. The vertical segment on the left has a height of 5 units. The vertical segment on the right has a height of 13 units. And the distance between the 2 points where these vertical segments meet the diameter is 24 units. Our goal is to find the area of the entire semicircle. So, the first thing we need is the radius, because the area of a semicircle is based directly on the radius. Let's call the center of the semicircle O, and let the radius be R. Now, we don't know exactly where O sits relative to those two vertical segments, so we introduce an unknown distance. Let the distance from O to the foot of the right vertical segment be x. Since the total distance between the 2 feet is 24 units, the distance from the foot of the left vertical segment to O must be 24 minus x. Notice that we are simply splitting that total distance of 24 into 2 parts. One part is x, and the other part is 24 minus x. Together, they give 24. Now, connect the center O to the top of the left vertical segment. This new line reaches the curved boundary of the semicircle, so it is a radius. Therefore, its length is r. Look carefully at the triangle on the left. We have a right triangle because the vertical segment is perpendicular to the diameter. Its height is 5 units. Its horizontal base is 24 minus x, and its hypotenuse is r. Whenever we have a right triangle and know two sides in relation to the third, the Pythagorean theorem tells us that the square of one leg plus the square of the other leg equals the square of the hypotenuse. So here we write 24 minus x whole squared plus 5 squared equals r squared. Now let's expand this carefully. 24 minus x whole squared means we multiply 24 minus x by itself. That gives us x squared minus 48, x plus 576, and 5 squared is 25. So the equation becomes x squared minus 48, x plus 576 plus 25 equals r squared. Now combine the constant terms. 576 plus 25 is 601. Therefore, we get x squared minus 48x plus 601 equals r squared. Keep that equation in mind because we're going to use it in just a moment. Now let's move to the right side of the diagram. Connect O to the top of the right vertical segment. Once again, that line starts at the center and ends on the semicircle, so it is another radius, meaning its length is also r. This gives us another right triangle. The horizontal base is x, because that is how we define the distance from O to the right vertical segment. The vertical height is 13 units, and the hypotenuse is er. So, using the Pythagorean theorem again, we have x squared plus 13 squared equals r squared. 13 squared is 169, so this simplifies to x squared plus 169 equals r squared. Now here is the key observation. We have two different equations, but both of them are equal to the exact same quantity, r squared. That means we can set the two expressions equal to each other. So we write x squared minus 48, x plus 601 equals x squared plus 169. Now, pay attention to what happens next. We have x squared on both sides, so we can subtract x squared from both sides. Those terms cancel completely. That leaves us with negative 48x plus 601 equals 169. We now want to isolate x. Subtract 601 from both sides. On the left, the 601 disappears, and on the right, 169 minus 601 gives negative 432. So we get negative 48x equals negative 432. Now, divide both sides by negative 48. The negative signs cancel, and 432 divided by 48 is 9. Therefore, x equals 9. That gives us the horizontal distance from the center to the right vertical segment. And this is exactly what we need to find the radius. Now let's go back to the simpler right triangle equation, which was x squared plus 169 equals r squared. We already found that x equals 9, so now we substitute 9 for x. This gives us 9 squared plus 169 equals r squared. 9 squared is 81, so we have 81 plus 169 equals r squared. Adding those two numbers gives us 250. Therefore, r squared equals 250. Notice something important here. We actually do not need to calculate r itself. Normally, we might take the square root of 250 to find the radius, but that would be unnecessary because the area formula already contains r squared. So we can go directly to the area. The area of a complete circle is pi multiplied by r squared. Since a semicircle is exactly half of a circle, the area of the semicircle is pi multiplied by r squared divided by 2. So we write area equals pi multiplied by r squared divided by 2. We already know that r squared equals 250, so substitute that value directly. The area becomes 250 pi divided by 2. Dividing 250 by 2 gives 125. Therefore, the area is 125 pi square units. If we want a decimal approximation, we use pi approximately equal to 3.14159, and multiplying 125 by pi gives approximately 392.7 square units. So the final answer is 125 pi square units, or approximately 392.7 square units. The main idea to remember from this problem is that the two radii create two right triangles, and both triangles must have the same hypotenuse. That allows us to write two Pythagorean equations, set them equal to each other, and eliminate x squared. Once x is found, we can determine r squared directly, and then calculate the semicircle's area. If this explanation helped you see how the two triangles connect to the same radius, take a moment to like the video, subscribe for more math problems like this, and leave a comment with your answer before moving on to the next problem.